Alright, so hello everyone. So we'll be discussing the problem on LeetCode region cut by slashes today. The problem number is 959. You can find it on the LeetCode platform. So I'll be going through the problem statement first, and then I'll be explaining my approach for it, and then I'll be coding the solution for it. Alright, so let's firstly just read the problem statement. We have been given an n into n grid that is composed of 1 into 1 squares, where each square consists of a forward slash or a backslash or a blank space. These characters divide the squares into contiguous regions. So we have been given an array of strings just like this, by which we can represent our given grid. So a backlash character has been represented by 2 backslashes. Alright, so let's perhaps now move on to a sample case for it. For the first sample case, we see that we have here this thing. We have here one slash. So this one slash divides our given grid into 2 regions. So the answer is 2. Similarly, for the second one, we have a single slash, but it is unable to divide the given grid into any number of regions. So the answer for this case would be 0. Alright. So yeah, moving on to my approach for it. Yeah. So let's say we have a grid like this. Let's say we have a 2 cross 2 grid. Alright. So I have 4 squares in it like this. Alright. So what I'll be doing here is that I'll divide one given square into 4 sub triangles, something like this. Each one of them. You can see it like this. Similarly for this. And similarly for this. Alright. So I'll name these regions like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Alright. So I'll be checking now based on what characters we are having, whether the characters would be able to divide the square into some regions or not. Let's say if I have a forward slash character like this, something like this, I'll use a different color for this. If I have a character like this, this character would surely divide my given square into 2 parts. 0, 1 would be connected and 2 and 3 would be connected if my character is this, right? Similarly, if my character is a forward slash character, a backslash character, in that case these 2 parts and these 2 parts would be definitely connected. And if no character is present, that is, it is a blank space, in that case it is very clear that all of the 4 regions would be connected either ways. Alright, so that would be one connections. Now coming on to the next connection, which can be between 2 different squares. That is between something like between this square and between this square. Alright. Yeah. The second connection would be something like this. Alright. It can be something like I'll be discussing it now. I'll just rub this. I'll make a new figure for you. I would rather like to explain it in the given problem here. Alright. Yeah. Explaining that here. Alright. See. This is my grid. I'll not go into the details of the numbers and all. You can have it afterwards. One like this. Another one like this, third like this, this and this, right? 0, 1, 2, 3. Now if you see this particular square, it can be connected to right, left, up and down, 4 squares like this. Let's assume it's not the starting square, it's a general square. So for a general square there would be 4 possible cases: right, left, up and down. So if I'm connecting this particular complete square with its right square, in that case this guy and this guy, both of these will be connected. So the number for this one would be 4, 5, 6 and 7. And if I'm connecting this square with the down square, like this complete square, in that case this guy would be connected with this guy. So the number for this guy would be 6, 7, 8, 9, 10 and 11, right? Alright, so if I am taking the left case. Let's say if I have a generic square which is connected to its left square. So in this case there is no left square, so I'll take this one as the current square. If this is the current square and it had to be connected to its left square, then in that case also we see that this guy would be connected to this guy. Alright, so for this one would be something like this, and this would be connected to this. Now moving on to the last case, that would be up case. The previous square in the previous square in the previous row, that is the square just above this particular square. If I'm connecting it with something like this, so in that case I'll take this case. So this would be connected with this. That would be the case. Alright, so we'll be decoding some generic formulas for all connecting all these squares, and I'll be explaining them in the code now. So once we have connected all these squares like this, we'll be connecting them by the disjoint set union approach. So if you're not familiar with this approach, I'll recommend you to firstly go through some tutorials based on disjoint set union and then perhaps move to this question now. Alright, so now moving on to the code. You see, I'll first take a DSU vector. Alright, I'll not make a size for it. Let's take n as my grid size and let's resize the DSU to be 4 cross n cross n. Alright, I have resized it to 4 cross n cross n. I've done that because we see that in our case we are dividing each square into 4 regions. So the total number of elements for the final grid would be n cross 4, because each square has been divided to 4 subregions. So yeah, that will be the resizing. Now I'll make the parent for each one of them as themselves. That is what we conventionally do in case of disjoint set union. So I'll mark DSU of I as I. Alright, now I'll write my DSU function for getting the parent. Let's say I am finding the parent for the ith node, or you can say the ith member of this entire grid. So if I is equals to DSU of I, that means it is the parent of itself. So in that case I'll just return that number because I found the parent. Else I'll recursively return the parent for I. I'll get the parent for DSU of I so that I reach the root. It is something like this. Let's say I have a node like this, connected like this and this and this. So if this is the parent of this is the parent of this, I am recursively calling it, and then I'll finally reach the root node. So that would be my answer in that case. Alright, so now I'll just move on with the code now. Alright, so I've got my getParent function. Now I'll go to the each grid member, the original grid member. Alright, so I'll go to the formula for it. If I'm at some particular point, if I'm at some particular point, let's say, so if you visualize it to some extent, you will get to know that the generic formula for that particular part of the grid is 4 cross I cross n plus j. Alright, You'll have to visualize this a bit, then you will get with the formula. So that's easy. Now if the current element of the grid, if it's, let me just see, if it's not what we have been given a forward slash or a backslash. Alright, so if it's not something like this, so what did we discuss? If it's not this character, then surely it will be this character, or you can say this character. So in that case we discussed that 0, 1, 2, 3, the character is, it's not this, so it's this. So 0 and 2 will be connected and 1 and 3 will be connected. So I'll union my root and root plus 2, and I'll union the next elements, that is root plus 1 and root plus 3. Yeah, and now I'll write my union function. This is also part of the disjoint set union approach, so you will first need to refer to that. If I'm connecting this and this, so firstly I'll find the parent of I, next I'll find the parent for j. If x is not equals to y, then I'll set the parent of y as x. So basically I'm connecting this. If x is equals to y, then there's no need for connecting them, that is they are already connected, they already belong to the same parent. Alright, now coming on to the next part. If grid of ij, it's not equals to, we have taken the forward slash, now we'll take the backslash. We are representing the backslash by this. Alright, if that is the case, in that case, well, that's interesting. If it's not this, then it's this, and that case 0, 1, 2, 3. If it's not this, then it can be this. Then in that case 0 and 1 will be connected and 2 and 3 will be connected. Alright, so union find C, 0 and 1 are connected, and 0 and 1 and 2 and 3 are connected. Yeah, so that would be one particular case. Now we'll move on to the next cases. That would be the case wherein you are connecting some adjacent squares. That is a particular square, you are connecting it with its side squares or whatever you call it. Alright, just a minute, I will just visualize that. Yeah, so in that case we see that if I'm taking this square, I told you that if there's no particular square present above this square, so we'll first need to check whether there is a row present above this particular square's row. Alright, so what we'll do is, it's simple, we'll just check if I minus 1 is greater than or equal to 0. Only then we can say that a row will be present and there would be a square. So in that case we'll just connect root element, because root along with root minus 4 cross n plus 3. Yeah, I'll just discuss this formula. How did I get to this formula? Alright, just a minute, give me a minute. No, I need to redraw it. Alright, no problems, I'll just redraw it for you once again. Yeah, if I was having something like this and I needed to connect this with this, so what I would have done, 0, 1, 2, 3, and this one would have been 8, 9, 10 and 11. If this is the root, then I need to connect 8 with 3. So what if 8 is root, then what will be 3? Root minus 4n plus root minus 4n would give me this element. Alright, so I just need to add 3 now. So root minus 4n plus 3, that will be the relation for this one. Alright, yeah, that will be it. That would be one case. Now I'll check the next element. If I need to connect this particular square, let's say if I need to connect this, with this, something like this, right? If I need to connect this with this, then what I'll do is I'll check if there is a next row present or not. So that can be checked by I plus 1 is less than n or not. If that is the case, then I'll do union find root comma root plus 4 cross n. It's simple. You will just need to visualize this. If this is root, then you're going to this element. So the formula for this would be root plus 4n. You'll need to visualize this on your own, that how do you deduce a generic relation for each one of them. You'll have to deduce it on your own. You can take it by example as well if you want. If n is 2 here, so root is 0. So 0 plus 2 into 4, that would give us 8. And when we decoded it, the number for it, this block was 8. I told you that in the previous iterations. Alright. So that would be one relation. Now I'll need to check the left and right blocks. I'll firstly check the left block. If that is greater than equal to 0, I'll first need to check whether there is a left block to it or to the current block or not. If there is, then I'll union find my root plus 1 along with root minus 4 plus 2. Alright, I'll explain this now. This is also very simple. This is even simpler than the previous ones. You'll get this easily. Alright, 4, 5, 6 and 7. Alright, so let's say this one is our current root element. Now I need to connect it to its left block. That means I need to connect 5 with 2. So if this is root, then what will be this? Root minus 4. Of course, that's very obvious. That is 4 minus 4. You can see it by this example, and also you can visualize it on your own. So that this would be root minus 4. And then you need to go to its second element. That's it. So that would be plus 2. Simple as it can be. Alright. So that would be my third relation. And coming on to the last relation, that would be if j plus 1 is less than n, that is I'm connecting it to the right block of it. So that would be union find root plus 1 along with that would be root plus 2, sorry, because we are connecting this with this now. So if this is root, then this would be root plus 2. Alright, so we are connecting a root plus 2 along with root plus 4, and that would be plus 1, I think. Yeah, because if this is root, then this is root plus 4. I'll use a different color. If this is root plus 4, and this is root plus 4 plus 1, this complete block. Alright, so in this way we have established our connections. Now we just need to check how many different parents are there, because the number of different parents would denote the number of components. This you know from the concept of disjoint set union, that we'll be dividing the given graph into some number of components. So each graph will be having one component, and each graph will be having one parent, and each different parent would denote a different component. Alright, so I just need to check the different number of parents for each one of them. If I is equals to parent of I, that means the given node is a parent of itself, that is, it has no particular ancestor. So if it has no particular ancestor, then there is only one possibility, that it will have some children or it will have no children. In either ways it will form a separate component. Alright, so I'll just increment my count variable here, denoting that this has been divided into one particular region, and this count variable now just give me the total number of regions. So I think that should do it. I'll just try and run the sample test cases here firstly. Let's just check for any compilation errors firstly. Alright, so we are having a compilation error here. Let me check what it is. Alright, we have resized it to this. That's absolutely fine. Alright, DSU. Alright, if integer I, this is absolutely fine. I'm just returning the parent. Alright, this is okay. What I think there's some problem here. There might be some problem here. If this is not equals to a backslash and root plus 1, root plus 3, root plus. Next what I'm doing is alright, I got it. So this should be root. No, this, I think this is fine. I need to check it for the backslash. Root plus. For the backslash, we are joining root and root plus 1 and root plus 2 and root plus 3. That is absolutely fine. Alright. If it's not equals to that. Alright. For the forward slash, we need to do 0 plus 2, 1 plus 3. Alright. Now this, I think this seems fine. So there might be some error with the formula. Let's just check for it. You need to debug your solutions every time. So yeah. Alright, got it. This should be root plus 3. We discussed that. If I'm joining this guy with this guy, so this is root and this is root plus 3 and this is root plus 4n. Yeah, so I think that should be the only problem here. Let me check if there's any other problem. Alright, I don't think there's any other problem. Let's just go through it first. Alright, we're still getting an error. Oh, that's a typo here. Alright, nothing much. I think this should be fine now. That was a typo here because I was going out of range of the array. See, we are getting the correct output for this case. Now let's try another case. Alright, this is also right. Go for the third one now. Oops, let's just wait for a second. This is also right. Alright, so I'll just submit the solution now. See, so yeah, the code is correct and it has passed all of the test cases. You can see that here. The speed is also pretty decent to me as of now. So yeah, that will be it from my side. I would refer all of you to try this problem on your own first and then perhaps move to the solution. And please leave your feedback in the comment section. That would be really helpful for me as well. So thank you and have a nice day.